Hello, everyone, and thanks for coming. Welcome to our first Python lesson organized by RICHCODE. RICHCODE is a nonprofit organization dedicated to expanding accessibility for computer science and STEM education. Founded in 2021, we have since served over 200 students. And today we're going to be talking about an introduction to Python. Wait, can everyone hear me?
Yeah.
Okay, just making sure. Okay, so if you are new to programming, you might be wondering, why should you learn Python? So we're going to go over some main points about why Python is a preferred programming language for many, especially for beginners. And we're going to talk about TIOBE, which stands for the importance of being earnest, which is a website that gathers data about the most popular programming languages and some other um, cool features about Python and why it's easy to learn and its values of simplicity and readability and many of its real-world uses. Okay, so the importance of being earnest, or TIOBE, is basically a website that ranks the most popular programming languages. Many people in the industry often refer to this, and every month they have a new list, which is updated. And for September, Python is the most popular programming language. So that's a fun fact about Python. And you can see C++ and Java come in close, second and third. So Python is known for its simplicity and readability. Those were some of the design principles when the founders of Python invented the language. So here on the next couple of slides, you'll see this some code in multiple programming languages that all try to do the same thing, which is print hello world. So you can see here, we have shell script, we have C, and then here we have C++ and Java. And then you can take a look at Python. So what do you notice? Does anyone want to share? So yeah, Python is the shortest compared to all the other languages. We say it has the shortest boilerplate code. Um, yeah, so there's no convoluted any methods to begin the code, and it's way easier and shorter to type as well. Yeah, so no curly brackets. That's a well-known feature of Python. Yeah, so like compared to Java or C++, there's no need for a main method or a class. We can just print right away. So yeah. And next, Python is also a very powerful programming tool. It's very concise and beautiful with its syntax, and also it has many different packages that it can support. Okay, so someone asked, what does language equals 4 mean? So basically all of these different languages, we're setting language equals 0, language equals 1. So when we print it out, it's going to say, for example, for the first one, language 1, I am the shell, hello world. And then for C, it's going to say, or no, this one's going to be language 0, and this one's going to be language 1. It's going to say language 1, I am C, hello world. So basically, we have a variable, which is the number, and then when we print that out, it's going to print language followed by the number. So this is just so that it looks cool when we print out and we have a comparison. Yeah, does that answer your question? Yeah, so the %s here, basically, it's going to get replaced by the language variable in the end. But that's not the focus of today's class. We'll get into the syntax and variables and the print statement, obviously. But today I just want to give an overview for Python and also help you guys install Python and get things running. Yeah, so someone asked slash n. So slash n is a character for a new line, but that's not super important right now. Yeah, so as I was saying, Python also supports most modern cloud platforms, and it's also used widely in artificial intelligence and machine learning. On the slide here, some of these are just listed a few very popular frameworks that we use. For example, like TensorFlow for machine learning. So yeah. Okay, so next we're going to get started with installation. So there's many different ways you can do it. Um, the most simple way is just using Google Colab because it doesn't involve installing any other things. Um, so yeah, before we do that, I want to explain kind of the difference between an editor and an IDE. We also wrote a blog post about this on our RICHCODE blog a while ago. You can go to blog.richcode.org to read it. But an editor or a text editor is basically um, often used for debugging and for large projects. Some examples include Microsoft Word, Sublime Text, Notepad++, and Vim. Um, Wait, actually, this got mixed up. IDE is IDE is for debug and large projects. So an IDE stands for an integrated development environment. It's often much more complex and has many debugging tools, so it's very convenient for developing large projects. And VS Code is an IDE, and so is Jupyter Notebook and Google Colab. Okay, does anyone have any questions? Okay, then if not, we'll get started. I want to show everyone the most simple way to do it first, which is using Google Colab. So in order to program in Python with Google Colab, you're going to have to sign in with your Google account. So I can show everyone. Okay, is my screen still sharing? Seems like it's not. Okay, can everyone see my screen? Okay, so this is the website for Google Colab. It is collab.google. And basically here it's just the web page. You can click open Colab, and I'm not sure how this looks like for you guys. But basically, another way to do it is you can click in Google Drive, you can click on new in the top left corner, and then you can click on more, and you should see an option for Google Colab. If not, if it's the first time, you can click on connect more apps and then find Google Colab to install. Yeah, so it's Colab is short for collaboratory, and it's this one right here. So I'm going to give you guys a couple minutes to do this, and if you have any questions, I'm happy to help. Um, So if you're on an iPad, I'm not sure how you're able to do this. An iPad is not preferred for programming. So if you can use a laptop or computer, that would be great. With the keyboard. What do you mean? Okay, some people are saying it works. That's great. Then try creating a new Google Colab file, and if you already know some Python, you can play around with it and print hello world. Oh, so you're on an iPad with a keyboard? That also might be hard. Are you able to access Colab? Okay, if not, then you can try using Replit, which I'll show later. But you can try going to your browser and trying to go to Google Drive and see if that works. Yeah, so the reason we're doing this is because we need a Python environment to do any kind of development. Okay, if people don't have any more questions, we can get started with Google Colab. Hmm. Yeah, okay, so over here I have some other ways you can do it. I'll link the slides after today's lesson if you want to try using like VS Code or Jupyter Notebook, which involves installing Anaconda. But for now, we'll just proceed with Google Colab because it's the most easiest way. So yeah, so in Google Colab, um, let me share my screen again. There is no homework for this class, but many of you are also registered in the American Computer Science League or ACSL contest. Um, so I would also recommend looking at last year's videos on our YouTube channel covering topics specific to ACSL. Those videos don't cover any programming, so that's what this class is for. So yeah, there are also a ton of practice problems for that. And if you also want to do some Python practice, um, we can also provide those if you would like. So yeah, so does everyone see like a page similar to this with like file, edit, view, insert? Like is everyone on this page? You might not have the blocks over here. Oops. But is everyone here? Okay, so seems like not everyone is here quite yet. I'll wait like another minute. Um, so yeah, I can oops, let me see. Okay. Let me show how to create a new file. Um, yes, this video will be posted on YouTube after after the lesson is over. Okay, so if you have successfully installed Google Colab, you should be able to click on New and then More, and then see an option for Google Colab. And then click on Create. And then you should see a page like this. Does anyone need help on this? Okay, so it would be great if you can share your screen or like describe what kind of problem you're having. Um, or I can create a breakout room, and Jaden, another one of our instructors, can help those who need it. Yeah, so let me create a breakout room. And then for the rest of us that have Colab set up, we can continue. Okay. Can you join the breakout room? Yeah, so if anyone needs any technical help with setting up Google Colab, you can feel free to join breakout room number 1, and then we'll continue. Okay, and then if that's the case, I'll just, yeah, Michael, can you join breakout room number 1, and then we'll help you over there.
How?
Um, on the bottom of Zoom, do you see a button for breakout room? Or I could try assigning you to a breakout room. Yeah, do you see an option to join breakout room number 1? Okay, I think we're fine. Okay, so let me share my screen again. Yeah, so let's continue. So in Google Colab, on the main interface, you should be able to see 2 buttons here, for code and for text. So what's nice about Google Colab and also Jupyter Notebook is that you have the option to have these blocks for both code and for Markdown text. So I'll explain what Markdown is in a moment. But for now, you can play around with this. And also, if you open a new code block, on the left-hand side, you should see a play button. So when you click on the play button, that will basically execute any of the code inside of that block. Okay, does everyone see these? Um, okay, then I'm going to explain what Markdown is. So Markdown is a lightweight markup language that you can use to add formatting elements to plain text documents. So some of you may be familiar with this. If you've definitely seen something similar, if you use like Word or like Google Docs, you'll basically see like different heading levels. So this is something that Markdown can do. So for example, I can demonstrate in here. So if I click on new text, this is with one hashtag, this is heading 1. So on the right-hand side, you'll see a preview of what it looks like. And on the left-hand side, this is Markdown. So heading 2, this would be heading 3. So yeah, this is a way to style your text, and it's not Python, it's not a part of Python, but if you're using Google Colab or Jupyter Notebook, you might see like these comments or annotations. So that's why I'm explaining this over here. And then this is a paragraph. And then you can also do like cool things. This is like italics. Oops. Yeah, so you can play around with this. This is not super important, but you can also look up like a Markdown cheat sheet easily online, and it'll teach you like how to do headings, how to make your text bold and italics. So you can play around with this or look at it if you want. So yeah. So someone asked, is this like prettier? This is not quite the same as prettier. So prettier, if you're referring to the extension in VS Code, that's for styling your code and syntax to make it look pretty and make sure like all the indentations and spacings are correct. Markdown doesn't do that. It's just simply like a markup language for like doing like text. Does that answer your question? Okay, yeah, I hope that helps. Okay. Then, okay. If we have time in the end, I can help everyone like set up VS Code if you're interested in doing that. But Collab also works just fine. Okay, so that's it for setting up. So I want to make sure everyone can do Collab. So is everyone fine? Okay, then we'll get started with some actual Python. Yeah, so now let's talk about some basic data types in Python. Um, okay, someone only has a phone and can't try right now. Yeah, if you can't access a computer, then um, maybe you can try later. But for now, let's continue. So yeah, so in programming, something we like to do when we're learning a new language is hello world. So here you can look at, oops, I think this website is broken. But basically, um, here is a collection of hello world in many different programming languages. You can look at that for fun. But for now, basically, if we want to display any kind of text in the console, we will use the print function. So the print function will be followed with parentheses, and inside of quotations, you can print out any text. So for example, if I run this block right here, it's initializing. Yeah, so it printed out hello world. So let's try to make this work for everyone. Hey, does anyone have any questions? Okay, then let's continue. So someone earlier was asking what the /n means. It basically does a line break. So over here we see the rest of the sentence after the slash n gets printed on a new line. So that's what it does. So whenever you do slash n, Python will recognize that special character and it will know to do a line break. Okay, so we can also print out numbers in Python. So inside of the parentheses, you can also print out a number like 123. Yeah, and this is only for Google Colab and Jupyter Notebook, but you can print things out without the print statement. So if you just put only the text or the numbers you want to print out, it will print out the last one. So over here, I didn't use a print statement, but it still printed it out. But it will only do it for the last line. So you can see the ABC over here did not get printed out. So this is something that's unique to Colab and Jupyter Notebook. And then another important thing to note is that you cannot concatenate strings with numbers. So what I mean by that is if you try to print something like 123 plus like hi, this will give you an error because you cannot add an int or like a number and a string together. So in Python, anything in quotation marks, this data type is called a string. You can think of it as like any text, including numbers. So for example, 1, 2, 3 inside um, a quotations is also a string, whereas like 123 without the quotations, this is an integer. And in Python, you can, like Jeremy said, you can add strings together. This is called string concatenation, and basically it will just put the strings like side by side, like right next to each other. However, this does not work if you're trying to concatenate an integer and a string, unlike some other programming languages. In Java, you can do this, and the result will also be a string. But in Python, this will give an error. So I can do a few more examples. So for example, if you do like 123 plus 1, this will not give you 124. This will give you 1231 as a string. Does that make sense? Since we're adding two strings here. Yeah, so another feature about Python is that it uses weak data types. So you don't need to explicitly declare the data type of a variable before you initialize it. So we'll get to variables later. So some other very basic data types include a float. A float is basically any decimal kind of number, um, unlike um, unlike whole numbers, which are integers. And another very commonly used data type is the Boolean. So a Boolean is a binary data type with only two values, either true or false. So this is very powerful. And in the beginning, you can think of it as like an on-off switch, but it's used to do logical conditions and more complicated decision making in Python and other programming languages. So in Python, you can Booleans are either true or false, and you can declare them by using a capital letter for the T and the S. So something else that you can do is you can do type. So type is another function, and whatever you pass in here, um, it will give you the data type of whatever you passed in. So over here you can see in quotes 1, 2, 3 is going to be a string. So str is short for string. Any questions? Okay, if not, then we will move on. Yeah, so next, let's talk about doing basic mathematical operations with Python. So this basically works like any other like it's basically like a calculator. It's very intuitive, and so basically you can do addition by using the addition symbol, and if you print this out, Python will do the addition for you. Okay, so if you still need help setting up, you can feel free to join the breakout room. Um, our awesome instructors, they're helping those who need help. Yeah. So this works the same for addition, subtraction, and for multiplication, um, we use the asterisk symbol. So that's Shift 8 on most people's computers. So this will do multiplication. And for division, since we can't really type out a division symbol, we use the slash. So the / will do division. And in Python, Python also follows the standard order of operations that you would see in math. So we can also use parentheses to specify the like importance or like the precedence of the order of operations. And so most of you probably learned this in elementary school, but we have an acronym called PEMDAS. So it's parentheses, exponents, division, multiplication, addition, and subtraction, where multiplication and division have the same precedence, which is higher than the addition and subtraction, which also have the same precedence. And whenever we have uh, operations of the same precedence, we will go from left to right. And let's get into some special operations. So the first one here is whole number division. So this is 2 forward slashes, and it works very similar to division, but it will truncate the decimal part. In other words, it will give you the whole number result of the division, but it's always going to be rounded down. So you can think of it as we're doing regular division, but we're going to basically remove everything that's after the decimal place. So it'll be rounded down. And next, the percent symbol is used as a modulo operator. So basically it calculates the remainder of the division. So 33 divided by 5 has a remainder of 3. So the mod operator will give you 3. Does this make sense? Any questions? If not, then let's move on. So these are just some more examples of using negative numbers. And then here we have exponents. So remember that multiplication is 1 asterisk. So doing powers or exponents is 2 asterisks. So you can think of this or read this as like 5 to the power of 2, which gives you 25. So similarly, 5 to the power of 3 or 2 asterisk 3 will give you 125. So this is the Python way of doing exponents. Okay, so another thing you might see often in development, especially if you're um, working in a collaborative environment and working on a larger project, or even for yourself, is to add comments in the code. So for So comments are basically notes that you want to leave either for yourself or for someone else to read. These are not read by the interpreter, so basically the computer will ignore everything that's a comment and it will not cause an error. So comments can be whatever you want and the computer will simply ignore it. So good comments are usually short, easy to read, and to the point. So in Python, we can write comments using the hash tag, the hash symbol. And any text after that will be part of the comment, so the computer will not read it. So these are two examples of comments. You can do a comment on a line on its own, or you can add comments after code. So the first part will be read by the interpreter, and the second part will be a comment. And sometimes one line of comment is not enough. Sometimes we may want to write multi-line comments, which could be more descriptive paragraphs for larger portions of code. So in this case, we're going to need 3 opening and closing double quotes. So how you would do this is you would have 3 single or double quotes. Either is okay as long as you're consistent. And anything between that will be a multi-line comment. So what that means is we can have comments that span multiple lines. And yeah, so either single quotes or double quotes, both are okay as long as you're consistent. And I also forgot to mention this for strings. Um, Strings can be also enclosed with either single quotes or double quotes. So here is an example of double quotes, and you can also do single quotes. This is also a string. Um, there's no there's no difference between the two. It's just a matter of preference. But what you cannot do is to mismatch them and do something like this. This will not work, and Python will give you the squiggly underline telling you there is going to be an error here. Before we move on to variables, does anyone have any questions? Okay, if not, then let's move on. So variables in programming describe a place to store information, such as numbers, text, lists of numbers, dates, and so on. So in math, a variable is usually an unknown value that we're trying to solve for. Um, but in programming, it's slightly different. In programming, they're not unknown values, but like in math, they are um, basically a symbol or something that can store the data. So is there a limit to how many lines of comments you can have? No, there's no limit. Um, you can add as many comments as you want, but typically, like, you shouldn't have that many comments. You only need comments if you're trying to explain some kind of code to yourself or for your teammates if you're working collaboratively. Okay, so variables are in Python, we can declare a variable with a variable name followed by an equal sign, and then the value of the variable, whatever we want, to on the right-hand side of the equal sign. So you can name variables pretty much anything you want, with some restrictions, like variables have to be one word. You can't have a space in it. But of course, there are good variable naming conventions. Um, this will depend on like um, how you're doing it, but typically the most common naming conventions are camel case and Pascal case. So um, camel case is like if you have a variable that is going to be many words, like what's an example? Um, like if you're trying to keep track of the score in a video game and you want to name it like game score, we typically since we can't do like have spaces in variables, like this will not work. It'll give you an error. So if we have many words that in the variable we're trying to name, we will typically make the first word lowercase followed by capitalized. So this is just a convention that we often use when naming variables to make everything consistent. Another way you can do it is game underscore score. It will depend on, you can use either way. It typically depends on like what you want, but just make sure it's consistent. And variables should also be short and descriptive. So basically, when you look at your code, you should be able to know what the variable does, and like what kind of data, like what specifically it's representing. So variables, once you declare them, they can be accessed and modified and used later on in the code. For example, we have a print statement here followed by the variables. So it will print the value held by the variable. So I mentioned this earlier, but in Python, when we're declaring a variable, we don't need to specify the data type. Python will infer the data type for you. So right here, we have a string. Right here, we have an integer. Python will automatically know it's a string and integer respectively. So another thing is that once you declare a variable, you can change it later on. So over here, this isn't changing. This is an example of changing values. So let me create one over here. So right here, I declared name as Richard. Let's try to change it to something else. So name equals Bob, for example. So now that we changed it, if we print out the variable, it will now be Bob. Yeah, so what this code over here is trying to show is that we have a variable called name already, which, okay, so name was Bob, but now we changed it back to Daniel. So I created a new variable called name2, and I assign it to name1. Basically, the new variable of name2 will now hold the value of name, which is Daniel. So we can assign variables to new variables, is what this is trying to say. Is it possible to make a simple game in this class? Yeah, so we'll have opportunities to do some cool projects later on, like tic-tac-toe or rock, paper, scissors. And we'll also get into some more competitive programming problems for the ACSL contest. So yeah, so when we are making those games, we're going to be using the console basically. And we won't be using any libraries for like for any graphics. Yeah, so that was a side note. So let's continue. So just like we can do operations with numbers, we can also do like operations with variables that are numbers. So over here, instead of, you see init coins is 20, but instead of doing 20 over here, we can use the variable instead. So one advantage of using variables is that variables can be dynamic, they can be changed later on, and instead of hard coding everything, we use variables, which makes it very convenient. So that if the variable is changed later on, we don't have to change that code anymore. We only have to change the place where we're changing the variable. So to illustrate this point, right now we have init coins equals 20. So we can also just do 20 over here, but if we change the variable later on, it will be very tedious because we will have to change. If we change it to like 40, then we're gonna have to change this to 40. And if we're trying to do that for a lot of variables, it's very inconvenient. So that's a major advantage of variables is that they simplify our code a lot. Yeah, so I explained the type function earlier, which basically will print the type of the variable. So now let's get into some more types of variables. So over here, we have a list. So what if we want to store many different things in a single variable? So that's where lists are very useful. So a list sounds like what it sounds like. Um, when we create a list, we use the square brackets, um, and all the elements of the list inside are separated by a comma. Um, a list is essentially a sequence of objects. And over here we have a tuple. So a tuple is very similar to a list. On syntax wise, we use the rounded parentheses instead of the square brackets. And for a list, the elements inside can be any data type, including integers, strings, etc. So we will talk about the specifics of the differences between lists and tuples in a later class, but essentially um, lists are mutable, which means they can be changed. So we can add, change, and delete elements from a list. And tuples are immutable, which means they cannot change size. So they have a fixed size. We cannot add or delete elements. Okay, so we have a Boolean here, and the none type is it's basically a data type of like none. So it has no value. It's kind of like null or void. It doesn't really have any meaning to it. Okay, so going down, let's talk about some more integer operations that you may see. So right here we have a equals 5, but what if we wanted to increase the value of a by 2? So if you already know it, we can just do a equals 7, since we know 2 more than 5 is 7. Or we can also do like 5 plus 2. We're increasing the value of a by 2. But another thing that sometimes students get very confused about is this. So in mathematics, this is not a legal expression. Um, we know that a cannot be equal to 2 more than itself. But in programming, in Python, this is okay. Because remember, in Python, whenever we're assigning or changing the value of a variable, the variable itself is always on the left, and we assign it to whatever value is on the right. So what this is saying is, first, let's increase the value of a by 2. So now it's 7. And then let's assign that value back into a. So that is what this line of code does. The line below it, a plus equals 2, this is a shorthand way of a equals a plus 2. They do the exact same thing. This is just a shorter way to express that same thing, and you might see it sometimes. So similarly, we can do a equals a minus 2, and the shorthand for that is a minus equals 2. This also works for multiplication and division in the exact same way. Does anyone have any questions? Okay. Then if not, let's talk about how big can an integer be? So back in Python 2, right now we're on version 3, but in Python 2, the size of an integer was limited to 32 bits. So that was enough to store an integer from around negative 2 billion to around positive 2 billion. So computers store data using bits. So a bit is basically a binary value of 0 or 1. We also talk about this in the ACSL Contest 1, number systems, binary. Um, so yeah, computers will store data in bits. And computers use binary. They don't use the decimal system or base 10 system that we use. So that means all integers are actually stored in base 2, in binary. And when we say 32 bits, that basically means we can store 32 binary digits, and that corresponds to the largest being a little over 2 billion. So any integer larger than that range will cause an integer overflow, which is like an error. But in reality, when we say 32 bits, actually only 31 bits of those are actually storing like the magnitude or like the number itself. The first bit is dedicated to the sign of the integer. So the first bit basically specifies whether the integer is positive or negative. 0 is for positive and 1 is for negative. This is some very technical details about like computers. So if you're interested, you can look up this further on your own. But in Python 3, an integer can handle any integer no matter how large it is. So basically, you can kind of go up to infinity or however large you want. So there is no limit. So right here, I tried to do a very crazy large number. So 10 to the power of 100, which I believe is called a Google, if I'm not mistaken. Someone can correct me on this. But it's also an integer, and it's going to be very large, obviously, and we won't get an error. So what's cool is that in Python, we can also do integers with other bases. So over here, this is an example of octal, and then we also have hex. So Python can recognize um, these other bases and number systems. But for the most part, you'll see base 10 for the majority of what you will see. If you want to learn more about number systems, you can refer to our YouTube channel. We have a video about it. I believe it's lesson 1 for the ACSL contest. And okay, let's move on. Python also has many useful math functions, apart from the typical like mathematical operators like addition, subtraction. There are some more functions that are included in the math package. So if you want to use them, you'll have to import the package first. So it's okay if you don't understand what a package is. We'll talk about this later in modules and packages. So here, as you can see, we have the value of the constant pi, so 3.14, and it goes on. And we also have E, or like Euler's number. But if you want to print these out, like the exact value, you'll have to do math.pi. And before you do that, you will need to import math first. Yeah, so I hope everyone is following along. You can do this in your own Google Colab as well. So some more useful math functions are floor and ceiling. So floor will round a number, a float down, and a ceiling will round a number up. So you can think of floor, a more formal definition for floor is like the smallest integer or whole number less than or equal to the number that we're trying to floor. And the definition for ceiling would be like the lowest number that is greater than or equal to that number we're trying to floor. Yeah, so someone asked, what is math.e? So E, or Euler's number, is a very famous mathematical constant that is used a lot in higher level math, like calculus, like natural log. So that's when E comes into play. This is not a math class, so you can look that up on your own. So yeah. So earlier we talked about how we can do exponents. So we can do exponents with 2 asterisks. But math also comes with a function for exponents. It's called math.pow, which is like short for power. So here, the power function specifies 2 parameters or inputs. The first is the base, and the second is the exponent. But the key distinction between using this function and using the 2 asterisks is that math.pow will always return a float. So even if 2 to the power of 3 is 8, it will give us 8.0. Similarly, the square root function will always give us a float as well. So even though the square root of 25 is a whole number 5, it will give us 5.0. And I'm not sure what this is. Okay. So I think we will stop here for today's lesson. Today we hopefully installed Google Colab, and we also talked about some basic primitive data types and some Python operators. Next time we'll continue with data types, and I hope you enjoyed today's lesson, and the slides and the YouTube video will be posted shortly after. Thank you, everyone.
Wait.
And for those of you still here, just a reminder that the first ACSL contest is, the deadline is January 12th, and it will cover number systems and recursion. And those videos are on YouTube as well.